정 교수님,
예, 안녕하십니까. 예.
네, 안녕하세요. 네, 제가 시간 맞춰서 들어왔습니다. 네. 어, 9시가 됐기 때문에 시작하도록 하겠습니다. Okay, let's get started. Today we have a very distinguished speaker, Professor Jung Hyung-gu from our university, College of Nursing. Um, he has a very interesting history of attending schools from KAIST to University of Waterloo, and then Stanford, and then University of Washington. So I think, we can learn a lot about. We can ask questions about his journey of studying as well. So today he's going to talk about the toward human-centered AI to improve decision making in healthcare. Professor Jung, it's yours.
Thank you, Professor Cha. Can you hear me?
Yes, yeah.
Good afternoon, everyone. First of all, I thank Professor Sang-Kyun Cha for inviting me to this seminar and for giving me the opportunity to talk about my research. Today, I'm very excited about to talk about my research efforts in the field of human-centered artificial intelligence. Over the past few years, my research has focused on the early stage development of innovative technologies through design and engineering to support people with special needs across multiple domains such as health, social media, accessibility, and sharing economy. For the rest of the talk for today, I will talk about the concept of human-centered AI first, and next, I'm going to present my recent research efforts. First, I'll be presenting AI-based dietary assessment, and second, I'll talk about how I used method and techniques for um, explaining evidence by data visualization. And after that, I will conclude with my future research directions, with including development of tools that leverage data by reflecting the needs and barriers of AI stakeholders, as for my future research. My research has focused on leveraging AI and multimodal data to improve healthcare and accessibility these days. I hold my PhD in biomedical and health informatics from the University of Washington School of Medicine, and I have experience in both academia and industry, including research in Microsoft and Xerox PARC. And currently, my team is working on developing AI-driven dietary assessment tools for older adults with diabetes, and as well as a multimodal data framework for periodontal disease care and big data-driven web accessibility solutions for people with visual impairment. My research group is called Human-Centered AI Artificial Intelligence Lab. I enjoy working with excellent students on the intersection of three domains, such as AI, HCI, and healthcare. For more information about my research group, you're welcome to visit the website hkl.snu.ac.kr. First of all, I'm not sure how many people are currently here, but raise your hands if you have heard about ChatGPT, and raise your hands if you used the ChatGPT before over the past 3 weeks. Yeah, it took 2.5 years for Amazon to obtain 1 million users, and it took 10 months for Facebook to get 1 million users. However, it took only 5 days for ChatGPT to reach 1 million users. So that's very fast. This shows that how many people are very excited about AI and how quickly new technology is changing our world. However, such technology was not something new in our daily lives. I personally enjoy using an app, Google Photo, because it enabled me to organize photos efficiently. So for instance, this app product automatically tags uploaded pictures using its own artificial intelligence software. And each new photo app actually unfortunately mistakenly labeled a black couple as being gorillas. So this case reminds us that AI needs careful oversight and diverse training data to prevent discrimination. In 2016, Microsoft launched Tay, which is also one of the chatbot targeted at 18 to 24-year-old in the United States. The Microsoft Bing teams aimed to experiment with and conduct research on conversational understanding. However, Microsoft's attempt at engaging millennials with artificial intelligence has backfired hours into its launch, with waggish Twitter users teaching each chatbot how to be racist. Such a disaster showed that probably AI could be observe biases from the internet and must be carefully monitored. And also, it was also a wake-up call for AI developers to build safeguards and ethical protections and into AI systems. But one interesting thing is that probably there are a lot of researchers and scientists who used most recent latest models. But however, due to the such data which was used for training such models, we found such incident. Although AI system hold promise for improved diagnostic and prognostic detect decision support and vaccine discovery, and I wanted to show you this one cycle which shows how real world discrimination leads to biased data. So for example, first of all, on the right hand side, there's a data, and this data is current. Actually, we really wanted to probably improve any model or by creating tool, and this tool could be tested, and after ultimately in healthcare scenario, this could lead to clinical decision making. This shows that actually even though the data set was such a small data set previously at the first time, but what if the data is biased, it will ultimately actually affect decision-making process. So this might be very critical because this might affect influence ultimately humans very critical scenarios in healthcare system. So therefore, now we can imagine that probably it might be very important to think about how to build model efficiently and effectively, but still we might need to think about in order for us to make sure that the model is makes sense, we might need to think about how to probably obtain data, probably which might be more trustable and not biased for training such data. So therefore, a lot of researchers are aware of this situation right now and these days, and a lot of researchers try to focus on how to overcome such limitations of existing technologies. And human-centered AI could be one of the way of how to solve such problem. And this theme is that basically, rather than displacing human abilities, we really wanted to create a system that amplify and augment rather than displace human abilities. So let me tell you one example of how human-centered AI framework is working. So this framework includes 3 different main components. One is that ethically designed design, such as people want to create AI solutions that avoid discrimination and maintain fairness and justice, and do not want to replace human, which is now you will find that on the top. And second is that on the left-hand side, which is called technology enhancement, and technologies that fully reflect human intelligence, which further enhances AI technology to reflect the depth characterized by human intelligence. Now you can imagine that probably it's very important to think about how to make AI system ethically, but still we really need to make sure that any system we want to develop actually work accurately. And third, we call a human factored design. This one means that we really wanted to create AI system to make sure that such solutions are explainable, comprehensible, useful, and usable. So let me give you an example. For example, let's say that one older adult is wanting to learn about how to interact with ChatGPT, and probably older adult who are aged or 65 or older wanted to learn how to use ChatGPT. Probably the person might want to how to create a prompt, and probably the older adult really wanted to generate images using ChatGPT. But still, it might be very difficult. He might feel challenged because there are a lot of instructions available on the YouTube. So he tried to watch YouTube and wanted to learn it, but a lot of languages and terms, that is what he didn't expect. Probably he didn't want to learn probably anymore, because it might take much longer for him to to learn how to use it. So let's say that, for example, probably we might need to think about if really wanted to create AI systems that meet with the needs of such stakeholders. So therefore, probably even though we really wanted to make a system to make sense and accurate, probably we really need to think about whether such AI system actually satisfy with the needs of such specific populations as well. Over the past few decades, years, I wanted to show you one-dimensional framework. On the left-hand side, we can see human control, and on the right-hand side, you can find computer automation. So probably over the past few decades of years, humans, we really wanted to create a system that produce a lot of products very efficiently. Efficiently means that we really wanted to minimize how long it takes, and also we really wanted to minimize cost as well. So therefore, we really wanted to move to maximize the level of computer automation. That is what we humans have done so far. Which means that actually we wanted to make sure that actually we really don't want to care anymore, because it's automation. Probably this is also important, because we really wanted to make sure that probably labor cost is increasing, as well as human probably might create any errors or mistakes. So therefore, computer automation allowed us to make such product more accurately and efficiently and effectively. However, in the field of human-centered AI, we really wanted to make sure that we wanted to maximize two different levels of human control and computer automation. So let me give you an example. So for example, one person is wanting to drive an automated car, and probably the car really, actually the person doesn't have to actually drive a car, and we can imagine that the car is moving automatically, so therefore it would automatically stop and then run, and the human doesn't have to control anymore. But my question is, probably some of us in our seminar really probably one person, probably hobby would be driving. Probably some of them really wanted to drive some coastline, therefore really wanted to enjoy. But would it be possible that? Probably yes. What if the car is not working automatically, which means that a human really probably wanted to take control. This is a very important concept because decision is made by AI system, but we really wanted to make sure that human wanted to take the decision or AI wanted to take the decision. AI can still generate a lot of list of recommendations, as well as AI can recommend great suggestions. So really, in our daily life, we actually we are currently always think about where to go for good food or where to go for good drinks, and we can choose one of them. But what if AI just recommends one item, which is the best one? And because which was generated by a highly scientifically complicated model, therefore which might be excellent question, answer. But would you willing to follow the decision rather than choosing one of them? Probably, actually, if you choose one of them by yourself, that might not be a optimal solution. But actually, human ourselves, we really wanted to make sure that we wanted to have control. So in our human-centered AI, we wanted to maximize two different levels of human control and computer automation. So therefore, one question is, how might we create human-centered AI? Let me go back to our scenario in healthcare. Instead of showing you a one-dimensional framework, now I wanted to introduce a two-dimensional framework that defines there are situations that require higher levels of computer automation as well as human control. On the x-axis, you can find that computer automation low to high, and y-axis you can find human control low to high. So this two-dimensional framework shows how creative designers, or probably system engineers, are able to imagine highly automated systems that keep people in control. So in the case of pain control designs, we can imagine 4 different cases. For instance, non-automated morphine drop bag, lower left, was improved by an automated dispenser on the lower right. Now we can imagine that actually, first of all, and what if 2 levels are all both low? It means that each patient has no control at all, and also probably health provider really need to visit the patient, and the person might want to decide control morphine drip back. But when you go automatic dispenser, it means that still each patient has no control at all. But actually the health providers, actually the person also doesn't have to control, but probably automated system can determine how much the dispenser would work at the point. Now you wanted to go upper left, which is called the patient guided dispenser. This means that each patient has control. So patient feel that actually the person want more morphine, and the person would be able to control and then increase the amount of morphine. But at this point, actually the health provider doesn't have to provide any automated system. Now let me go upper right, and which is called a patient-guided clinician monitored system. So this is the status where each patient has control, and as well as the system is automated. What it means that, as I told you before, what if the car is moving automatically, but at some point human want to drive a car like that. Actually, the in usual daily life, probably the system is working automatically, but at some point, if a human, a patient wanted to have control, the person might able to determine how much and how frequently the person want to get additional morphine. So therefore, in our human-centered AI system, we really want to make sure that we wanted to actually maximize the levels of two different values, human control and computer automation. Ancient astronomers, with a few exceptions, saw that the Earth as the center of the solar system, with the sun and planets revolving around. In the 16th century, however, Copernicus reframed astronomy by making a convincing case for a sun-centered model, which he showed to be more accurate, thus that enabled us to better predict and further discover. So let me give you an example. So on the left-hand side, we can find AI-centered. AI-centered means that, for instance, the emulating human behaviors with AI engineering focused on replacing human performance. Now we can imagine such different types of technologies, such as pattern recognition and natural language processing, computer vision, and such technology and methods allowed us probably rather than actually human still do it, but rather than that, we really wanted to replace human performance. We are able to borrow the power of the AI system. One big difference between AI-centered and human-centered is that AI-centered right now you can find the human is around it. So which means that actually each human, each person, if any human wants to interact with AI, the human need to learn how to interact with the AI system, and also human need to actually be experienced. So therefore, we can imagine that in parallel, so some people are very experienced in using, for example, ChatGPT, and probably the person probably shows a better performance rather than any human who has low experience in using ChatGPT. This is one example. However, human-centered AI, now we can imagine that a human is centered. It means that the main focus is that we wanted to enhance human performance by making systems reliable, safe, and trustworthy. This is one case I explained before. We can imagine, for example, older adult who wanted to learn how to use ChatGPT. Probably each older adult, we might think that actually older adults who are aged 65 or older might be the same. Actually, they might not be true. Because some, for example, my mother is very good at interacting with such ChatGPT. However, probably my father is still not familiar with using any smartphone technology. Which means that probably it might be important to think about probably even though we think that every single older adult has similar or same experience, probably they might face different challenges. Therefore, they might have different needs. So what it means that probably we really need to think about understanding experiences, how and why and what they have experienced using such technology. And also we need to think about actually what they need when interacting with such AI. So therefore, rather than asking each older adult to learn how to interact with such AI system, probably we might think about how to make such AI system that actually meet with the needs of each stakeholder, which is called human-centered AI. So in this field, we really need to think about probably how to understand experience of such users by using any probably existing methods like design thinking process. So one question I wanted to ask was, can you use human-centered AI for improving decision making? One domain I'm very excited about using AI in healthcare is that there are a lot of different types of domains and a lot of domains available, such as patient-facing technology, such as AI chatbot, wearable devices, personalized genetics, mental health, and women health, and skin. Those are all, we can imagine any such technologies that actually support any patient with any diseases or chronic diseases. And on the right-hand side, we can see that doctor-facing system and methods, such as medical records, some tools for analyzing medical clinical data, and systems such as medical imaging tool, as well as a lot of operating systems, which was currently being used in every single hospital. And also, we can find two additional domains, such as telehealth. For example, now we are currently able to use such technologies like Zoom. And even though telehealth is some countries legal and the other countries not legal, but probably we have a little bit experience during the COVID-19 period, right? So, for example, the one person wanted to show my symptoms to my physicians, and the person can make a decision, and probably we can get some prescriptions to get the proper medicine. And also in the field of research, a lot of AI methods was used for drug discovery. So a lot of technologies currently, we can imagine that such technology was used for better outcomes in multiple different types of research. One thing I wanted to tell you is that I showed you different domains, each other, but we can imagine that actually probably a lot of audience are very interested in probably data science and AI technology, and which is actually probably most of in the domain. We can imagine that we use almost same or slightly different but same approaches to deal with such different types of data. So therefore, one exact thing I'm very interested in is that I can use one technology and one method, but I can apply such models and my techniques and knowledge to different domains. So now let me move on to the next phase. I wanted to introduce my recent research efforts, such as how I developed AI-based platform to support multiple stakeholders for better healthcare. Over the past few years, I have developed multiple different types of components for creating AI-based platform to support multiple stakeholders, such as health providers, researchers, and patients for better healthcare. So for example, now we can see three different stakeholders, and also actually there's a red colored text. One is called clinical data, which was actually provided by health providers. So clinical data means such as a patient's sample of blood, urine, or body tissues. And genomic data is data related to the structure and function of an organism's genome. Genomic data includes information like the sequence of molecules in an organism's genes. Let me I wanted to show you one example of patient-generated health data. This is from patients. And now you can imagine that probably this is data from patient. Probably not. Actually, I'm assuming that actually I'm not the patient, but I wanted to say that actually potentially if some of them, any of them could be potentially could be a patient. What it means that actually any person can actually the individual could able to generate such data, such as one example is such as blood clot monitoring system would generate such number. And also we can imagine that, for example, diet tracking, how much I ate in what kind of food, what I have eaten so far, and also step counts. That is one example of patient-generated health data. Additionally, and we can imagine that, for example, what kind of videos what I have watched over the past few weeks on YouTube could be actually one of the example of patient-generated health data, because history of such a video, watching video, could be actually implies by probably trend of my mood and biorhythm, and probably my probably the what I have watched so far might affect my behaviors as well. So therefore, one thing I wanted to tell you is that actually we can imagine that different types of data from different types of multiple stakeholders. Now I wanted to show you a very red color circle, because this is a domain I focused on for my PhD dissertation. And now I wanted to show you that this actually very small arrows as well. This shows one interaction between a patient and the patient's family members. And you can imagine that an interaction with the patients and different types of people, such as family members, friends, and caregivers. So what it means that actually each row is actually one research topic, and we really wanted to actually engage people to interact each other, so that we really wanted to probably make sure that how to create such technology to better support such patient, as well as support interaction among those people. So ultimately, what it means that actually after analyzing such a multimodal data set, we wanted to analyze so that we can imagine that we can get such as a list of clinical guidelines, and also we can predict the diseases. Diseases means it could be like a COVID-19 situation. That is one example in public health. And also I can imagine that disease prediction means like basically the tumor detect prediction. And also health behavior change. It means that probably this system would ultimately generate a list of recommendation to make sure that whether what kind of food, for example, I need to avoid, for example. This is one example of how we can leverage such system to create such a good recommendation. So this is one example of how I developed such a system for digital therapeutics. So which means that I focused on creating tools that enable patients with diabetes to collect the patient-generated health data and share the data with healthcare providers. One example was photos taken by older adults with type 2 diabetes. So this photo was used for measuring the portion size of a food item they have consumed so far. So therefore, we collected two different types of images. One is that we asked them to collect the images before they eat, and we also additionally asked them to collect the image after they eat. So therefore, we can actually calculate the difference between one to the other. This is one way of how to calculate the portion size. And such collected data was actually one way of using it is that we can analyze such collected data for detecting food items as well. So therefore, ultimately, we really wanted to develop dietary assessment system that which generates clinically meaningful action items for patients with diabetes. I actually wanted to emphasize that clinically meaningful action items. The reason is because during my college years and master's years in School of Engineering, I focused on creating a lot of different types of prototype. But it was great because I was very excited about creating novel technology. But still, it was actually quite not sure whether such system could be used in real world scenario. But in actually our healthcare scenario, we really need to think about whether such system actually makes sense clinically. That could be actually deployed in the future in hospital settings. Because that is very important, rather than saying that F1 score is 0.7597, which might not be important in real world. We really need to think about because very highly validated system, because they might affect actually the human's life directly. So therefore, I wanted to say that in healthcare domain, if some of them might be interested in developing the system, we really need to think about how to create the system clinically meaningful. So we found that actually the patients are very interested in obtaining validated action items from health providers. So therefore, rather than saying that, oh, the calorie and protein, oh, you're concerned this kind of food, but rather than generated by probably AI system, I'm not sure whether each patient actually really wanted to use this data because the data was not from health providers. So that is the other important factor of to make sure that we really need to think about whether each patient has their own different needs, and really need to think about how to make the system to satisfy with such needs of such stakeholders. Now let me move on to the next topic. I want to show you how I developed an explainable AI model and interface through data visualization. There are a lot of scenarios. That's what happens in our real scenario in hospital. And critical ethical dilemma in healthcare is end-of-life decision making. In many cases, doctors must determine when to withdraw life-sustaining treatment, but defining the right moment is very complicated. While family members may see signs of hope, hospitals assess the medical fertility of continued care. This conflict often leads to legal and emotional battles, as seen in recent cases. But the question is, what if the very highly validated AI system is deployed in a hospital, and the AI system now can generate recommendation to health providers? And can we truly trust AI system to decide whether an oxygen mask is no longer necessary, especially, for example, if cost becomes a factor? Probably, even though, or let's say that the wearing mask costs a lot, and probably the system estimates that it might not be good idea just to take off the mask. Actually, for the family member, it might be difficult situation, even though it costs a lot. But let's say that what if AI system did not tell anything about why it happened, but probably the physician just want to follow the AI's decision. Can you still want to follow the decision? Probably I was the person, if I'm the person who is investigating methods and technologies in AI, probably I might the person who might want to trust the AI system. I might be the person who should follow the AI decision. But even though if I were the situation, I'm still not sure whether I can trust the AI decision, even though I'm aware of the fact that AI system is highly validated. So this is one diagram which shows how explainable AI helps users make a better decision. So one thing I wanted to tell you is that probably, even though AI system is great, but we really need to think about why why someone is hesitated to follow the decision. Probably we might need to think about why why each stakeholder didn't want to follow. One example of why I want to do that, probably we might want to know why the decision has been made by such AI system. So unlike a traditional AI system, which provides results with explanation, explainable AI offers transparency. So the system generates recommendation and, more importantly, explains why it made that choice. So now you can find a lot of different types of errors. And each
네.
user then reviews explanation prior to
네.
the final decision.
회식?
For
그러네.
ultimately, each user is the person to make a decision. So in a traditional AI system, we can imagine a system that generates a list of recommendation, but we can find one additional layer, which is called explanation interface. So that shows that why this decision was made by the system. So therefore, each user can now say that, oh, it makes sense, and then the person can probably make a decision. So this approach builds trust and improves accountability and ensures AI supports human judgment rather than replacing it. A lot of existing studies, I found that a lot of researchers focused on developing methods for how to make AI explainable. But I found one missing component. A lot of AI explain AI system is available, which was published in top-tier conferences. But my question is, in with perspectives of a human-computer interaction, my question is, who might be the person who want to get information from AI system? Who will be the direct stakeholders who interact with AI system? So we really want to make AI systems explainable, but we really need to think about the target users who want to take a look at the evidence or explanation from the AI system. So this is one missing component. I always felt something missing in AI oriented papers. But recently, researchers identified 5 different types of stakeholders when creating such explainable AI, such as you can imagine that a regulator that who certify AI systems to ensure they meet satisfied standards, and AI developers who debug and improve AI models, while managers ensure compliance within organizations. On the right-hand side, we can imagine 2 different users as well. One is AI users who validate AI decisions with their own reasoning, and individuals affected by AI evaluate whether decisions are fair. So if in our seminar, so my question is, in which category are you currently? Probably you might be the person in AI user. Are you the person in, probably you might be the AI developers. You might be the person who regulate and review such AI systems in specific organizations. Yeah. I want to say that each different stakeholder has different needs. For example, let's say that AI user. I'm the AI user because I use ChatGPT. I can determine prompt. I can obtain results from ChatGPT. And actually, I do not follow. I do not copy and paste any result from ChatGPT directly. But I'm the person who think about whether this response makes sense. And then I can say that I'm the person like AI users. But some point, I'm the AI developer because probably downloading models and fine-tuning and generating by improving, and such activities make me to actually improve my performance. At that point, I can say that I'm classified as a AI developers. So this is quite interesting because we really need to think about whether stakeholders are in which category. So therefore, we might need to think about probably how to visualize such data or AI systems differently. Let me give you an example. So for example, this shows how data visualization is key part of explanation AI, especially in healthcare. So AI models help predict important outcomes like end of life situation, disease progression, and hospital readmission risks. By visualizing these predictions, physicians can better understand AI decisions and trust its recommendation. But one thing interesting thing is that probably there's a one chart R-shape curve, and there's a like tabular data side, data format, and also we can imagine like edge and node oriented graph. So what I mean is that actually there are a lot of ways of how to visualize such data. Probably some of you might be very familiar with ROC curve. Probably some of you might be very familiar with tabular format. So what I'm saying is that what in healthcare scenario, each patient has different knowledge and experience. Probably some of them might be very expertise in such data. So data-oriented person is very interested in such like ROC curve. But probably in our daily life, some other people might be only interested in rough and abstracted visualized data set. So let me, but one thing very interesting is that there are a lot of ways of how to visualize such data, but probably costing prediction. Do we really need visualization? Probably rather than to say that in the scenario of end of life, AJ mentioned before, probably it is quite and very seriously, significantly important to think about how to deliver such evidence to each family member. So therefore, visualization is much more important and essential. So therefore, one thing I wanted to tell you is that a lot of different this is a scenario, but probably actually data visualization at some point very necessary, but the other scenario probably we need less actually important than other scenarios. So therefore, I mentioned two different things. One is that we might to think about how to differently visualize such data set, and the other thing is that we really need to make sure that actually data visualization itself, actually we need data visualization. So let me go back to our example of the AI developers. I wanted to show you another example of how AI developers can use such data visualizations for making a decision. So I showed you earlier that actually I used technologies for collecting food images, and we collected the images to create classification methods. What it means that actually we wanted to classify different food into 27 different food types of food items that we wanted to recognize. For example, this is juice, this is milk, and this is coffee. But we've actually faced challenges in creating such model. The reason was because actually we didn't have enough data for some specific food item, but actually we really wanted to make sure that the system makes sense. So therefore, actually we created box plots of such data set we have collected. And actually, we were not sure whether this model makes sense. So therefore, we actually created such box plot. This chart shows a true positive rate of AI predictions across various dishes, such as you can find 죽, 나물, 김치, 해물, 탕, and 찌개, and you can find different types of data. As you can see here, the high accuracy category, and we can find some different category. this actually shows the quality of data set. We found that actually, for example, Namul is one of the example, which was prepared by seasoning plants, vegetables harvested from mountains and fields. And this is great because we found that any photos and food items like Namul showed guaranteed accuracy. However, on the right hand side, such as 조림, 지짐, 해물, or 탕, and this is one example, and we found that actually I'm the human, and I can imagine that probably left hand side, which is kimchi-jjigae, on the right hand side, probably actually I'm actually not sure whether this is 알탕 or not. But one thing I wanted to tell you is that in order for us to make sure that the model makes sense, one way of doing that is probably we can exclude any data set like 탕 or 조림, and we can guarantee that we can probably improve accuracy of such a model. But we really need to think about and how to classify 탕, 조림, and probably such dishes, because this dark box plot shows that actually this data set has actually low quality. So therefore, now I want to say that actually such a visualization probably would allow AI developers to make a decision whether which data set I can trust for training data, training model, and which data set probably we really need to carefully take a look to make sure that the data set can be used potentially for training such model. Now let me move on to the next one. I wanted to introduce future research directions toward human-centered AI in healthcare. One important we need to think about is that in healthcare, we really we aim to improve the quality and value in healthcare, and by developing tools and leveraging data reflecting the needs of barriers of AI stakeholders, such as healthcare providers, AI managers, patients affected by AI-based decisions. And also, we need to think about how to develop effective human-centered AI systems for improving decision-making in healthcare. So, for example, there are a lot of open source models available, and now we can actually access to different types of the model on Hugging Face. So, therefore, probably such a model could be used for creating effective human-centered AI system. So the other approach is that actually there are a lot of now recommended practices and guidelines by a lot of great researchers. And this shows one example of recommended practices from Google, such as one recommendation is that we need to use human-centered design approach. This is a design thinking process suggested by D-School, which was widely used in D-School and Stanford. And this is one way of empathizing, defining a problem, ideating solutions, and prototyping any functions using solutions generated in the previous stage of ideate and testing the prototype. So this is one way of how to make sure that we address the needs and barriers of stakeholders. And also, we need to think about how to identify multiple metrics to assess training and monitoring. So now you can imagine such as accountability, fairness, privacy, and transparency, explainability. But one thing very interesting is that in this diagram does not show anything about accuracy at all. So what it means that we wanted to make sure that AI system is guaranteed, AI system is accurate. Now we need to think about whether the AI system actually guarantees the level of fairness, actually guarantees a level of transparency. And also one very important thing is environmental impact as well, because this is something we really need to think about, because a lot of researchers are currently using AI models for actually minimizing environmental impact of any other different type of system. But actually AI itself is actually creating a lot of carbon emissions. So this is actually one of the way of how to actually make human-centered AI system. And additionally, we really need to think about how to examine raw data directly. Even though we have a small data set, we can still visualize such data set quickly and prompt rapidly, and therefore actually such small clue still impact actually to make a decision for AI developers. And additionally, we really need to think about the limitation of our data set and model, which could be used in the future. So by leveraging AI through mathematical modeling, data visualization, and design thinking, we can develop tools and methods that support users rather than replacing those people. So AI decision making, explain AI, ensure transparency while human AI collaboration builds trust. And the key goal of my research is ultimately create a system that empower people, helping them make informed and ethical decisions. So therefore, probably I hope AI-centered AI improves both efficiency and fairness in various fields, especially in healthcare. So as we move forward, future-driven AI, it's essential to make sure that technology serves the people. And in healthcare, this means that developing AI that improves the quality, and we really wanted to address actual needs of such stakeholders. And by focusing on human-centered AI, we can create such a system that are ethical, transparent, and beneficial to different types of stakeholders, such as patients, providers, and decision makers. Now, this is the end of my talk, and thank you. And now I'm ready to answer any question.
Yeah. Thank you, Professor Chung, for the great introduction to human-centered AI and its application to healthcare. So I was a little bit late in a hurry, and when I started, but I'm actually in Singapore. It's 27 degrees. There's a 25 degrees of time difference in the temperature. So I may be a little bit feeling hot now. So speaking of human-centered AI, I was actually in discussion with one of the co-directors of Stanford Human-Centered AI, which kind of initiated the Human-Centered AI initiative worldwide. And so maybe at some point we will invite him to give a talk. There's a professor called James Lindy, who is one of the human-centered HCI expert, but now he's a part of HAI. So that's for the future. But next week we'll have a speaker who's working right now on legal tech, legal AI. But he was previously the VP of engineering at Instacart, so he covers the consumers and also the legal experts. So maybe we can continue discussion of a human-centered AI next week as well. So now let's take some questions. Any questions? Please feel free to ask questions. We have around 280 students registered for this class. So there are many students, but feel free to ask any questions.
So I have a question for the one you slides about the diabetes.
Yes.
Professor Vincent Lee, yeah.
But I also pose a question. I think it's the Stanford using human-centric, and I think you using human-centered.
Stanford using human-centered.
Yeah, I think it's different. I think human-centric probably more close to the work here. I think there are some differences. Yeah. All right. So my question is, in your diabetes, yes, this slides. So when you analyze, how can you generate the action item directly? there must be, so you were including the doctor recommendation in the training, or I was thinking maybe you have a XAI to detect the important factor, to cause diabetes. Maybe you can using ALN to then explain or generate the action item. So how can you do this from analyze image and generate action item?
Thank you, Professor Lee, for the question. The question was how to generate action items, like whether the person ate more protein or the person need to limit the salt.
Yeah.
And this process is not actually automated. We really wanted to invite, I would say that rather than doctor, I wanted to say the dietitian. So therefore, what I said is that I really wanted to use a validated data, validated method. Validated method means that actually we used, for example, there are a lot of different types of validated methods like food records, 24-hour recall of like food frequency catcher. I mean, those are like three very traditional validated method. So what we did was, for example, 24-hour recall means that actually we invite dietitian and we invite a patient. So therefore, each patient need to meet with each dietitian. So that's why what we did actually at the time was that actually we asked the patient to collect the picture, and the pictures was used for finding any missing item when reminding. So therefore, what it means that actually action item was generated by a human rather than the system. But I mean, in the future, we really need to think about how to create a system. But the thing is that we really wanted to make sure that this is validated. So rather than using any item or for let's say the responses from ChatGPT, probably I don't know whether that is a valid method. But in the near future, we really want to make sure that probably data from any such AI model could be used as a validated method. That is one of the my future research direction.
Thank you.
Thank you.
Any other questions? I actually like to ask you about your journey of, you studied in I think at least four universities, and I know you worked for as a professor at two universities, and now this is the I think seventh probably. And so, what do you think about the differences in the education in different institutions, especially related with AI?
Thank you, Professor Cha, for the question. Yes, it was a great opportunity to attend the different types of universities. I noticed that I attended actually a lot of different types of, because I attended the private school, I attended the public school, I also attended the national school, and but one thing I found that actually was each environment, it was a great opportunity to experience resources. So for example, at Stanford University, I actually, it was impossible for me to utilize all the resources available, but actually it was true too, actually, when attending University of Waterloo or even University of Washington, I don't think I can use any existing resources. Yeah, I mean, resources are all available, and I was very excited about using such resources. So therefore, that is actually I felt no difference. But one thing I found that one big key difference is that probably how to meet diverse people. So for example, during my college at KAIST, actually it was quite difficult to meet with different people. But when attending, for example, Stanford University, and yeah, I found so many people from different fields. Even though I'm in School of Engineering, I found people who working in the Bay Area, and I found the people who actually in art, in design, and all the different fields. So that was therefore I can imagine that actually I started my job at Seoul National University since September last year, but I might be very interested in interacting with people with a diverse background at Seoul National University, because this is the I feel like very giant community. I feel like Stanford University, rather than other different universities or I have experienced so far.
Yeah. That's why I invited you here into this seminar, which, the many students and faculty with different background joined this seminar. So I saw some faculties in different schools, even today. Yeah. Okay. If there's no question, I'll probably have to end this session, and I'd like to thank Professor Jung for giving a great talk.
Great. Thank you again for providing me this opportunity. And if anyone be interested in learning about my research, I welcome. And then please visit my website, or please feel free to email me if you have any questions. Thank you again.
Thank you.
Thank you. Bye-bye.
Bye.